The third degree Maclaurin polynomial for f of x equals sine x is given by this. Stop right there, write down what you know. A Maclaurin polynomial is centered at 0. I am dealing with a degree of 3. This polynomial is used to approximate sine of 0.5. What is the Lagrange error bound? Okay, sine of 0.5, that means we have an x value of 0.5. I'm just writing the things that I know. Those things that I know went there in red, and let's begin this process. The more you write the formula, the more you'll remember it. So, absolute value of r sub n of x is, and this is the error, and it's given by this, x minus c, the n plus 1 over, and then n plus 1 factorial, and then the maximum value. And if you ever forget this, well, don't forget this. But really, it looks so much like the next term of a Taylor polynomial. That's your denominator, x minus c to the n plus 1, just make it positive. And then the n plus 1th derivative evaluated at some function, is at some x value z, but we need the maximum of that. So the components of this look a lot like the next term of a Taylor polynomial. All right, so here's what we're going to do. We are going to find the next term, in a sense, and just approximate it as best we can. We're not exactly finding it. We're approximating things and finding our room for error, and we're going to find our Lagrange error bound. So here goes. The fourth, okay? Because n equals 3. All right, well, x minus c, 0.5 minus 0, that would be 0.5. And we're going to raise it to the 4th power over, well, 3 plus 1. That's going to give me 4 factorial. And then I want the maximum thing that the next derivative could be. Okay, wait a minute. Wait. All right. Derivative. We have a function, but okay, the first derivative is cosine, the second derivative is negative sine, the third derivative is negative cosine, the fourth derivative is back to sine, and then you lose track of which one you're on, and that's fine. Technically, I want to know the maximum thing that sine could be, or cosine, or negative sine, or in this case, this particular case, we are dealing with f fourth derivative of sine, which is sine. The fourth derivative of sine is sine. But, when you're dealing with trigonometry, you will never, ever, just plain trig, not like some fancy thing that's been stretched or, well, stretched particularly, stretched or vertical shifted. When you're dealing with those things, the maximum thing it could be is 1. Trig graphs are stuck. Whoa, don't know what happened there. Trig graphs are stuck between 1 and negative 1. Just standard trig graphs. So the most you'll ever get out of this sine of z is 1. That's it. And if it was cosine, it'd be the same thing. If it was negative cosine or negative sine, it'd be the same thing. So let's keep going. This is going to be 0.5 to the 4. That's 1/2 to the 4th. That's 1/16 divided by 4 factorial. We'll make that 24. And then sine of z, again, biggest thing that could ever be is 1. Now, technically, I want to know the biggest thing it could be in the interval from 0 to 0.5. But if we're going to make a very conservative estimate, often we'll do that with sines and cosines and just say most it could be is 1. That's it. That's the furthest we're ever going to veer from the center. So we could, if you wanted to, find the sine of 0.5 and find the actual maximum within there and all that good stuff. We're not. That's it. That's all we need. So what I want to do, all I really need at this point is to find out what 1 over 16 divided by 24 is. So 16 times 24 is 384. That's all I need.